How does the order of operations apply to fraction problems? Recall that the order of operations is a convention that has been adopted to remove ambiguity from calculations. First, we calculate within symbols of grouping, working from the innermost grouping outward. Symbols of grouping include parentheses, brackets, braces, as well as big fraction bars, absolute value bars, and radical signs. Next, we simplify exponential expressions. Remember that an exponent will only apply to an expression that it touches. Then perform all multiplications and divisions, working from left to right. Multiplication and division have the same priority because division means multiply by the reciprocal. Finally, perform all additions and subtractions, again working from left to right. Since subtraction means adding the opposite, we can think of subtraction as a type of addition. Therefore, addition and subtraction have the same priority. For example, in 5 minus 6 times 7 over the quantity 8 plus 2, the fraction bar is an implied symbol of grouping. We need to simplify the numerator and denominator separately before computing the division. In the numerator, the multiplication of 6 times 7 has priority over the subtraction, and in the denominator, there is only an 8 plus 2 to compute. Now subtracting in the numerator yields negative 37 over a denominator of 10. Now whether a negative is in the numerator or in the denominator or out in front of a fraction is immaterial, so we could write negative 37/10. Consider a more complicated example. Again, the fraction bar is an implied symbol of grouping. In the numerator, the division has the highest priority since it's to the left of the multiplication. We get 7 plus 5 times 2 in the numerator. The exponent has the highest priority in the denominator, but the exponent is only applied to the 5 and not to the minus. So we have 4 minus 25 in the denominator. Continuing to simplify the numerator produces 7 plus 10, because the multiplication has the second priority. And the denominator simplifies to negative 21. Now we have 17 over negative 21. And again, we can put the negative in front of the fraction and write negative 17 over 21. Considering an even more complicated example, the fraction bar, again, is an implied symbol of grouping. So in the numerator, evaluating the exponential expressions has the highest priority. So we get 2 cubed is 8 and 3 squared is 9. So 8 plus 9 divided by 3 times 2 in the numerator. And we have 4 minus 25 plus 7 times 4 in the denominator. Next, we compute multiplications and divisions, working from left to right. So we get 8 plus 3 times 2 in the numerator, and 4 minus 25 plus 28 in the denominator. Performing the multiplication in the numerator produces 8 plus 6, and adding from left to right produces negative 21 plus 28 in the denominator. Now we get 14 over 7, which simplifies to 2.